Hello calculus students and especially general seekers of truth. In this video we are going to talk about linear approximation and how to apply it to some practical problems and how it works and relates to calculus. So let's start with a rather straightforward example that just asks us, okay, we want to evaluate the square root of 16.3 and we want to do it without a calculator. Hence, those of you who are genuinely seeking truth will especially love this lesson. And we want to approach this in a way that we could solve the problem, repeat the process for other square roots, and also generalize it for other functions. So this is what real mathematics is like at work. You solve a simple problem, but when you're done, you don't just stop there. You say, oh, what is it useful for other things as well? Because I know all of you could just plug this into a calculator and call it a day, but we want to stretch this problem solving a little bit further so we can generalize it for some things that may not be so simple with a calculator. So what are some ideas? Well, we can estimate, right? Estimating is perfectly good to do. We can estimate and we can say that, well, the square root of 16 is exactly equal to 4. So the square root of 16.3 is probably somewhere around 4, but it's probably a little bit bigger than 4. If you are quite sharp with numbers, maybe you'll be able to recognize that the square root of 20.25 is equal to exactly 4.5. And so then we can say that the square root of 16.3 must be somewhere between 4.5 and 4. And other than that, there's not a whole lot that we could do with this. We could make some more guesses. We could take, say, like 4.1 and square it and see what it is and then compare it to this. But without further knowledge, this is probably near the best that we could do. Okay? Now I'm going to show you how we can extend what we know about calculus to be able to get a really great estimate for this number, something that's better than just between 4 and 4.5. Alright, so the better idea for how to approach this approximation is to use calculus, and in particular tangent line approximation. And so I'm going to do this, complete this problem, and then we'll kind of review and understand a little bit better as to why it works. Okay, so what we're going to do is we're going to find the tangent line of the square root function at x equals 4. Find the tangent line approximation of f of x equals root x at x equals 4. Now some things I want to point out here. Why x equals 4? Because it's close to a place where we actually, I'm sorry, not x equals 4. How silly of me. At x equals 16. Not x equals 4, rather x equals 16. Now, why x equals 16? Well, because 16 is really close to 16.3, and we know the exact value of root 16. So we want to find a number that's close to the number that we're estimating and for which we know the exact answer when we plug that number into f of x. So this is actually going to give us our point, right? So we know that the point at the tangent line is 16.4. And now we need to find the slope. Well, the slope we can find by taking the derivative. So let's take the derivative of f prime of x. This is going to give me 1 over 2 root x. Okay. Because this is really equal to x to the 1/2. Taking the derivative of that, you pull the 1/2 to the front, and this becomes x to the negative 1/2. So hopefully that didn't trip you up too much. and we want to find the slope at x equals 16. So we're going to substitute 16 in here. So f prime of 16 is going to equal 1 over 2 root 16, which will give me, root 16 is just 4. 1 over 2 times 4 is nothing more than 1 over 8. Okay. Now, so the equation of the line that we have is that y minus 4 is equal to my slope, which is 1/8, times x minus 16. So you could possibly be wondering, well, why do we bother to do this? What good is this line? Well, let me show you. So what I have sketched over here is the graph of f of x is equal to root x. That's the black curve. And then I've also plotted this line here, y minus 4 equals 1/8 x minus 16. And if you will notice with me, near 16, the curve and the line are very, very close to each other. So near 16, like f of 16.3 is incredibly close to y of 16.3. So let's just say a few things here. I'm going to rearrange the y, this line here. This is going to be 1/8. And all I'm really doing is bringing the 4 over to the other side, plus 4. Right? So when we can say that near 16, near x equals 16, f of x, like the actual values of the curve, is very, very close to y of x, namely the values of the line. Now if you get far away, there's a great distance between the curve and the line, just as if you get farther away in the towards the positive direction, the curve and the line differ by quite a bit. But near 16, you see near this point of tangency, the point and the curve are really, really close to each other. So if we want to estimate, right, and this is the idea here, is to estimate the square root of 16.3, well, all we really need to do is plug 16.3 into y. So what this tells us here is that f of 16.3 is approximately equal to y of 16.3. And to complete this problem, now involves just us doing a little bit of arithmetic. So this would be equal to 1/8 times 16.3 minus 16, so 0.3 plus 4. Let's see, we can do this, maybe the simplest way is, well, 1/8 times 0.3 is really 3 over 10 plus 4. So this is equal to 3 over 80 plus 4, which is equal to, let's see, 323 over 80. And I've worked out the math for all of this, and I know that 3 over 80 is why is my pen all messed up? This is going to be about 4.0375. And I'll leave it to you to use your calculator and see if you're able to, you can compare this to the actual number. So what we've done something here is we've been able to estimate the square root of a decimal, and get an answer that's incredibly close to what your calculator tells you. And I should stop here and point out that your calculator doesn't know the exact answer either. Your calculator also is applying some sort of estimation techniques in order to get this answer. Yeah, so I just tried it in the calculator, and according to the calculator, the square root of 16.3, and again, I'm pointing this out, your calculator doesn't know the exact answer either. All it does is some other type of estimation. It says it's about 4.0373, whereas our approach here, without using the calculator, gets it to be about 4.0375. This number from the calculator is probably a little bit closer to the true answer, but our answer is pretty good too. It's off by 2/10,000ths of a single unit. All right, so to recap here, right, what we're able to do is estimate the square root of a decimal by using the tangent line, because near this particular point of tangency, 16, the actual answer and the answer on the line are very, very close to each other. Now, this only works if you're close to the point of tangency. If you were to use root 16 to estimate root of 37.5, which is way out here, then your answers are going to be off by a lot. But near the point of tangency, it's pretty good. Okay? All right, and this is just a first step. We're going to learn many other estimation methods that will build off of this same one a little bit later in the course. But this is a good starting point. I'm going to end this video here and start another one where we not only estimate, but we try to determine whether a number is, whether the estimate is an over approximation or an under approximation. Thank you for watching, and have a wonderful day.